Zoro's Lost Path. Zoro is trying to reach an enemy stronghold, hidden deep in a forest. The stronghold is exactly n units away. At each fork in the path, Zoro can choose one of two moves. A narrow shortcut, which moves him forward by 1 unit, or a longer scenic route, which moves him forward by 2 units. Because of his terrible direction, Zoro ends up completing every possible sequence of routes. How many distinctive sequences of moves can Zoro take to reach this stronghold in exactly n units? Write a recursive function that returns this number. Since we move at 1 or 2 units, we will use 1 and 2 as our base case. To solve this, let's say n equals 5. Now we go to the final step. We're going to start from the final step to see how he gets to 5. We know that to get to 5, he can only take a 1 or 2 unit step. He got to be at 4 or 3. So with this, we're saying that he took all the steps to get to unit 4 plus all the steps to get to 3, and then that would equal to 5. And our function will say sequences 5 equals sequences 4 plus sequences 3. Or since we use in terms of n, we'll say sequences n equals sequences n minus 1 plus sequences n minus 2. And when console log, we will get 8. Next, we use memoization to optimize our code. We do this by passing through a memo object like we did last time. Here we have the base cases, and n equals 1 and n equals 2. And now we have an in loop to loop through the properties of an object. Then we have memo n equals sequences n minus 1 plus sequences n minus 2. This is basically saying that if n is in memo, we'll return it. But if it's not, what we do is we add the result of sequences n minus 1 plus sequences n minus 2 to the memo. This way we don't have to make as many recursive calls. This allows us to use the function on a much larger number. Instead of 5, we use 30. When console logged, we get 1,346,269 as the total amount of sequences he could take if the enemy is 30 units away.